Hi, my name is Niko Peric, and this is my Lab 0 code submission. And for this Lab 0, I'll also briefly go overview prior to talking about Lab 0, talking about the exercises of Lab 0. I'll explain the code briefly, which is basic assembly. So at the first line here for Lab 0, we have at the first line Lab 0, we have movw.w, and this is copying a word from the source 01 to the hexadecimal address memory 200. Okay? And for the second line, same thing, copying a word 02 to the hexadecimal address 202, and so on. And for line A, what we have here is command clear CLR R7 to R10. This will clear and initialize the registers. Okay. And for line B, same thing as line Lab 0, except the important part to acknowledge is this right here is copying a byte from hexadecimal address 200 to R7. Same thing, 202 or R8 and so on. And these lines are commented out until exercise 3 of my Lab 0, and the purpose of this really, which is included in the original code, is I wasn't able to specifically modify or manually modify the registers with the given values or word for the registers. So I actually implemented this part here preceding line C to modify the registers for me, since I wasn't able to modify it prior to beginning the next step of exercise 3. Okay? And finally, we have here same thing as the above line, except copying a value from register 7 to R10. Except for here, we're adding but also adding a byte. It's also another important thing to mention. And here we're adding a byte from R8 to R10. Same thing here as well. And then we have our main loop. And we also have our 2 breakpoints here, which I will modify now. And we'll also debug right here. And so for here, we're starting our reset point. And we also have our main loop as well, which has a breakpoint. So when we initialize, and we also have R7 all the way to R10. Okay, and we run this. Everything in our program will then run all the way from line Lab 0 all the way to main loop, and it stops here because of the breakpoint as well. Okay, and then we can also see, since as everything ran, we can see that for R7 all the way to R10. This is in line with what I should have for the register values, and also for SR0000 and NGVC. Here also all 0, so negative bit, 0 bit, carrier bit, and the overflow bit. Okay? And that's it for exercise 1. Now for exercise 2, what I have to do is, before I begin, is soft reset the micro. And I begin here at the reset point and initialize the stack pointer as well. But only after I run this, only after I begin will then initialize stack pointer as it begins this line now. Okay. And so for exercise 2, also have to initialize, add a breakpoint at line B and C. Here, while keeping the breakpoint at the main loop line. So once I run this, it stops here at line B, and also you can see that preceding line B, at line A, all the registers were cleared. So 0000, all the way from R7 to R10. Okay. And now, with that done, exercise 2 memory manipulation. So from here, I would actually have to modify this specifically, and then once I run this program, it will go from line B to line C. And the reason why we're manipulating memory is because now I'm going to copy, say for example, the value at 200, which is the word 01, 2, from 01 to R7. Same thing here for 202. It'll be 02 to R8, and so on. Okay? Now you begin that. So 200 will be 02. Okay? And you can see that I modified it here, which is why it turned red. Same thing here. Same thing here. Okay? And now, once you run this, you should then get a modified value for registered R7 over to R10. So here, we can see again that R7 to R10 changed, in the sense that had I not done this, what would happen is we would have empty registers. Sorry, what we would have whatever value was present before at these hexadecimal addresses copying to the registers R7 all the way to R9. But instead we have our modified values that were copied all the way to R7 to R9. Okay? And there's nothing copied to R10, there's no instruction copying into R10, registered R10. Okay? And then here, once I run the code again, it will then stop at the main loop, and it will conduct operation at this point here. Okay, and then here we can see that nothing changed as well, other than for R10. Okay, which is 0015. And just because all the registers here were copying into R10, and then R10 also copied into the hexadecimal address in memory 206, as you can see right here. Okay? And then now for exercise 3, register manipulation, what I'll do now is open also, by the way, preceding this experiment, and sorry, throughout the experiment, SR I had 0000, and I'm not sure if I already mentioned this, but I also had for the negative bit, 0 bit, carry bit, and the overflow bit, all zeros, throughout the entirety of live 0 specifically, okay? Just in case any misunderstanding there. Alright, and we soft reset the micro again. And we again begin at the reset line. And now we'll move the breakpoint at line B and keep them at line C in the main loop. Okay, so only have our breakpoints here at line C in the main loop. And then what we'll do now is execute the program to stop at line C. And then you can see here the register value all the way from R7 to R9 change, which is in line with what we expected for the value for the beginning of exercise 3. So R1 would be 0001, R2 02, 03 for R3, and then 0 for R10 and the SR and the other NZVC. Okay. And now, for modifying the registers, what I would have to do is I would have to, since I wasn't able, by the way, since I wasn't able to modify the register specifically, so for example, R7, I would put set 0005, just as an example of why I couldn't. So you can see how it keeps reverting back to its original value. So even if I reset the program and I ran it again, it wouldn't retain these values. So again, 01, same thing really. So now what I'll do is modify register values. having these lines here. And when I reset it, what will happen is it will write these values in R7, R8, R9 as it should, okay? And also these are my original values preceding the register manipulation. So we begin with that. Okay, I'm going to begin this. And sorry about that, I would have to debug it to have the chain take effect. And you can see right here, 05, 01, 00. Okay, as expected. And then once I run this, I should then get modified registry values at the right here. So I have 0005 for R7, 0001 for R8, 0000 for R9, and 0006. And this is because the modified value for R7 and R9 here were entered, and it then added all the way to R10, which gave me a final value of 06. Okay? And this is because R7 and R8, R9 were just all zeros, right? As seen here. And that's about it. Other than that, thank you for watching my code review on LabZero. Other than that, that concludes it for LabZero. Thanks again. Have a good night.